Hi, my name is Emma Keller, and for our group project, we did MP4 modeling with mathematics, and it was between Peyton, Kirsten, and myself. And unfortunately, we were not able to get together to film this video, so what we did is we divided all of the slides up, so we each did between 3 and 4 slides, and we're all presenting on our own slides, so that it would be like if we were together doing our own slides. So, what is modeling with mathematics? Modeling with mathematics is a process of making sense of the world through a mathematical perspective. No matter what age you are, it could be as young as preschool, just figuring things out, all the way up to like college level, and even in people's jobs if that's the career they choose to follow. So, my slides start with the goals of modeling. One of the goals of modeling is the appreciation of the broad use of modeling. So it can be in whatever subject that you choose to do, like not only for math, but it can be used for science, literature, even history, to give them tools to problem solve. So in science, it can be like different ways to get to our solution, in the same way of math is like using the experiment and getting there and actually having a greater understanding, and using hands-on experiences for students, even of all ages, to get a greater understanding of the topic. Like most students, let's say a kindergartner is learning to tell time, and if you explain it in your words, no one will understand what you're talking about. But using like the little clocks they give them and actually understanding why the hands on the clock rotate is a great way of modeling to help the elementary school age students understand. And this can go all the way to high school. Let's say you're in physics class and you're trying to understand like inertia or gravity or different things like that. Like doing the experiments can help prove what you already know, that what your teacher taught you. So if the teacher lectures for 45 minutes and you don't really understand what they're lecturing about, but you can do an experiment and be like, oh, like I completely understand this because we're applying it to a real world basis. And then even simple things like having students use their own ideas and creating solutions to problems. And this applies more to math and science, but in lots of ways, in lots of problems, there are multiple ways to get a single answer. And I remember when I was in middle school, I would get in trouble for doing the problem how it made sense to myself. And the teacher would go, this is not the steps I taught you, but I would still get the correct answer. So the biggest thing is understanding that students can get from point A to point B differently. And if that's how their brain chooses to get them there, then you need to understand that and you need to accept that and treat it as still correct. And also, just goals of modeling is helping students remember things more and think more logically in the classroom instead of just taking in what the teacher tells them and not doing anything with that knowledge. Okay, so the 2 examples I did is I kept them with the same problem about the pools and the tile, but I just adjusted them per grade level. So the first example is kindergarten to 2nd grade, and I put Allie is designing a square pool, and each pool has a square center of the area of the water. Allie uses the gray tiles to represent the water and the white tiles to represent the outside tiles around the pool. And so you give them different questions, and these should be open-ended questions, but you want them to get somewhere. So what I put for question number 1 is for each pool, sort the tiles into the water is the gray tiles and the white tiles for the border. So this would be a great way to use little tiles in your classroom, is have them build the pool and sort them into 2 piles and then count them so they can see what takes up more area in all the pools. Would it be the water or the actual tile around it? And then once they do this, they can count the tiles in each pool, and are there more blue tiles versus white tiles? And then if you want them to put them back into the pool, they can move all their tiles and make the pool with the tiles. And then you get question 3. How many tiles are in the largest pool? And you can check your answer by building a square and counting them. So this is very simple, probably kindergarten, 1st grade. And then for the last one, once they've built all the pools, the smallest one to the largest one, they can tell you what patterns they see. And this is one of the ones where it's very open to interpretation of them. Like they might see the tiles have a different pattern, they might see the water has a pattern, they might see it as a whole, like they might see it as a fraction. It really just depends what level of kid you are. But leaving it open-ended like that, it really allows them to think about what they've learned. So then using the same example, but with higher level thinking. So this would be 3rd grade to 5th grade. So my example is use the same problem from the slide before, but with a higher difficulty level. So question number 1 for this one is build 3 pools and record the number of gray tiles versus white tiles in the data table. So this can really teach that age of children something that they'll have to use in the future for higher level math classes, like putting in all your data and understanding where it comes from, not that it's just a given. And So the question number 2 is, if there are 32 white tiles on the border, how many gray tiles are there? And this does a great way of, they can draw out, or if they have the math skills, they can just think 32. And then, because they know if there are 8 tiles around the border, that there are 1 pool tile in the middle. So they can either visualize or draw it, and draw 32 white tiles to make a square, and how many tiles would fit in between that. And then what you can do is how many tiles are in the biggest pool. And again, with the same level as the elementary school age children, they can either count, or they can use their math skills by multiplying the 2 sides, the length times the width. So in this age, you'd probably expect them to want to multiply, but it also gives them an option to, if they're not sure how to do that, they are able to count. And then, how can you make a pool with 12 gray tiles? Explain why or why not. So this right here is what they would do, is they would try to make 12 tiles into a perfect square. And so they would understand the rules of multiplying, again, the length times the width, and to see if it makes a perfect square, so they can put white tiles around it to make the tiles around the pool. And then again, for this question, it says, find the fraction of the gray tiles over the white tiles for all 3 pools. Is there a pattern? And since these are all square pools, there will be a pattern. And this is another example of an open-ended question to get the students to understand where you wanted them to get to, but also allow them to think it through for themselves. And then in everyday life, you can use these skills by like doing the math when you go to the store, like when you're doing clothing stores. It's like, if you want to know how much of a discount it is, you need to have those basic math skills. Or even like math can help you save money if you know all these basic math skills. And I use it every day with basic cooking skills and knowing how much I should do with that. So in summary, modeling with mathematics is a practice of making sense of the world. And this is a great skill that every single grade should be teaching all of their children. And it will just help them excel in their job field, in life, and just become a better student. Thank you.